By default, apps launch into the shared space. This is where apps exist side by side, much like multiple apps on a Mac desk space. People remain connected to their surroundings through pass-through. Each app can have one or more windows. They can contain traditional views and controls, as well as 3D content, allowing you to mix and match 2D and 3D. People can reposition a window to their liking in the current space, just as one might expect. Volumes allow an app to display 3D content in a defined bounds, sharing the space with other apps. Volumes are great for showcasing 3D content, for example chessboard. People can reposition volumes in space and they can be viewed from different angles. Volumes are Swift UI scenes, allowing you to do layout in familiar ways. And they use the power of RealityKit to display your 3D content. Sometimes you might want to have more control over the level of immersion in your app. Maybe to focus while watching a video or to play a game. You can do this by opening a dedicated full space, where your app's windows, volumes, and 3D objects are the only one appearing across the view. In a full space, you can also take advantage of ARKit's APIs. For example, in addition to system-provided gestures, you can get more detailed skeletal hand tracking to really incorporate the structure of people's hands into your experience. Your app can use a full space in different ways. You can use pass-through to ground content in the real world and keep people connected with their surroundings. And when you play spatial audio and render 3D through RealityKit, you will automatically take advantage of the fact that the device will continually update understanding of the room to blend visuals and sound into people's surroundings, making them feel that these virtual objects really belong in their room. You can also choose to render to a fully immersive space to fill up the entire field of view. This allows your app flexibility to deliver on creative intent of your app by customizing the lighting of virtual objects, as well as the ability to choose audio characteristics. These are the foundational elements of spatial computing: windows, volumes, and spaces. They give you a flexible toolset to build apps that can span the continuum of immersion. Here we can see an example of how you can stack cubes on a table using taps and then smashing them onto the table with your hands. The system automatically brings input from wireless keyboards, trackpads, and accessibility hardware right into your app. And the game controller framework lets you add support for wireless game controllers as well. Collaborating and exploring things together is a fundamental part of spatial computing. We do this through SharePlay and the Group Activities framework. On this platform, as on macOS, people can share any window, like this Quick Look experience. When people share a Quick Look 3D model, we sync the orientation, scale, and animations between participants, making it easy to collaborate while being in different locations. When people are collaborating on something that is shown in their space and that they physically point at, it is important that everyone in the SharePlay session have the same experience. This enables natural references such as gesturing to an object and reinforces the feeling of being physically together. We've added the concept of shared context to the system. The system manages this shared context for you, helping make sure that participants in a SharePlay session can all experience content in the same way. You can use spatial persona templates to further customize how people experience your content. Instead of allowing apps to access data from the sensors directly, the system does that for you and provides apps with events and visual cues. For example, the system knows the eye position and gestures of somebody's hands in 3D space and delivers that as touch events. Also, the system will render a hover effect on a view when it's the focus of attention, but does not communicate to the app where the person is looking. For many situations, the system-provided behaviors are sufficient for your app to respond to interactions. In cases where you actually do need access to more sensitive information, the system will ask the people for their permission first. An example would be asking user permission to access scene understanding to detect walls and furniture, or access to skeletal hand tracking to bring custom interactions into your app.